Adding and subtracting rational expressions, section 8.3. Yesterday was multiplying and dividing. Now we're going to talk about adding and subtracting. Fortunately, it's just like adding and subtracting fractions. And basic part of that is you have to have a common denominator. Okay, and when we have that, it's all pretty good. So section 8.3, adding and subtracting rational expressions. Use a common denominator to add or subtract rational expressions. So rational expressions, again, look something like this up top here. Now notice that both the denominators are the same. So because the denominators are the same, I can combine my numerators, okay, and put them over top of one denominator. And now that they are over top of one denominator, I look to combine like terms. So right up here, I'm going to combine like terms. 6x plus 2x gets me 8x. 4 minus 8 gets me negative 4. And my denominator stays the same. So I get 8x minus 4 over x plus 5. Alright? So again, it's just very similar to adding and subtracting fractions. Think of it as, 1/10 plus 3/10. Well, how would you add fractions like that? 1 plus 3 gets us 4 over the common denominator 10. That's exactly what we're doing today. The only difference is they're rational expressions and not just whole numbers. So we're going to have to combine some like terms. Subtracting is going to be the same. Okay, we're going to subtract all the same here. So 4x minus 3 over 2x minus 1 minus 8x plus 2 over 2x minus 1. Notice my denominators are the same. So I can subtract combine like terms of my numerator. Okay, so we're going to look right here. And that's 4x minus 3 minus 8x plus 2. Now, if you don't like to subtract a quantity, remember you can change subtraction to a positive and then add the opposite, or basically just distribute the negative and you get the same answer. Alright, so if you distribute the negative, you get 4x minus 3 minus 8x minus 2. And I'm going to combine like terms here. 4x minus 8x is negative 4x. Negative 3 minus 2 is negative 5. And I get negative 4x minus 5 all over 2x minus 1. And remember, I'm still going to state my extremes where the denominator cannot be 0. Okay, so remember the denominator cannot equal 0. So let's look at number 1 here. I have x minus 5 over x squared minus 4 plus 3x plus 2 over x squared minus 4. Okay. So we're going to add or subtract here. So I have x minus 5 over x squared minus 4 plus 3x plus 2 over x squared minus 4. Notice my denominators are the same. So I write it over one denominator. Okay, x squared minus 4, right over the one denominator. And now I'm going to look to combine like terms. X plus 3x gets me 4x. Negative 5 plus 2 gets me negative 3. And I write that all over x squared minus 4. Okay, the denominator stays the same. I look to combine like terms. Now I need to state the extremes. I need to state the extremes here. Okay. Recognize I can factor x squared minus 4. That factors to really, that comes out to be 4x minus 3 over, that's that difference of squares, x plus 2, x minus 2. So my extremes here, remember my denominator cannot equal 0, so x cannot equal what two values, Andy? 2 and negative 2. So my answer would be 4x minus 3 over x squared minus 4, and x cannot equal 2 and negative 2. Okay. Number 2, again, set up very similar. The only difference is now it is subtraction. So 7x minus 5 over x plus 3 minus 4x minus 1 all over x plus 3. My denominators are the same. So I put them all over the one denominator. And now I have 7x minus 5 minus 4x minus 1 all over x plus 3. Again, remember I can distribute the negative, so I make that addition, subtraction, in addition. I could distribute the negative if I wanted to, just to simplify it with addition terms. And now I take 7x minus 4x, and I get 3x. Negative 5 plus 1 is negative 4. All over x plus 3. And now x cannot equal what value, Jack? Negative 3. Nice job, sir. And that'd be my answer right there. Good work. Let's try number 3. Very similar here. I have 2x minus 1 over x minus 1 minus 5x plus 4 over x minus 1. Okay. Are my denominators the same? Yes. So I can write it over one fraction. So I get 2x minus 1 minus 5x plus 4 all over x minus 1. Okay, and again, I can rewrite that and distribute the negative if I wanted to up here. So I can distribute that negative, which would get me negative 5x minus 4. Okay, and that's just distributing that negative. And now let's combine like terms. 2x minus 5x is negative 3x. Negative 1 minus 4 is negative 5. All over x minus 1. And x cannot equal what value, Reagan? 1. All right, so again, very similar to adding and subtracting fractions. The only difference is now they're rational expressions here. Try these 3. Okay, take a couple seconds to try these 3 and find the extremes as well. All right, let's go through these here. Number 4, when you add combining like terms, what do you get, Garrett? 3x plus 10 over 3x plus 7. Nice job. And my extreme would be what then, Sage? X cannot equal? Yeah, x cannot equal negative 7/3. And remember, that comes from the denominator cannot equal 0. So basically, if you had to, you could set the denominator saying it can't equal 0, and then just solve for x. So subtract 7. And you get 3x cannot equal negative 7. Divide that by 3. And that's where I get x cannot equal negative 7/3. Okay, remember, that just comes from the denominator cannot equal 0. Number 5. 8 minus x minus 5 minus x over x over minus 3. What do you get when you combine like terms there, John? 3 over x minus 3. Nice job, sir. Yeah, your x's do cancel out. Nice job. And then x cannot equal what value, John? X cannot equal 3. Nice job. And last but not least, number 6. Bless you. 5x plus 2 over x squared minus 1 minus 3x minus 7 over x squared minus 1. When you combine like terms, what did you get there, Reagan?
2x plus 9 over x squared minus 1.
Nice job. And then x cannot equal what values, Reagan?
1 and negative 1.
1 and negative 1. Nice job. Okay. So again, that's the majority of what your assignment is today. However, some of your assignment will also include problems like these. Where, well, what happens when I do not have common denominators? Okay, so again, what happens if I don't have common denominators? Well, typically then you need to multiply. For instance, let's say I had the fraction, we know, let's say 1/2 plus 3/4. And I said, hey, combine like terms there, add the fractions. Well, what would you have to do to the fraction 1/2? You have to multiply the 1 and the 2 by 2, right? We have to get a common denominator. So you have to multiply by like 2 over 2. And then we get 2/4 plus 3/4. Well, it's the same thing here in rational expressions. You have to multiply by what is missing. So I'm going to take my terms here. And the first thing you want to do is you want to factor it down. Find out what is missing. So when you factor it, you get x plus 3 and x minus 1. Well, my other fraction has x minus 1 already. So what term is my second fraction missing? It's missing the x plus 3. So then what do? Well, I multiply the numerator and denominator by x plus 3. Okay, so I multiply numerator and denominator by x plus 3. That then gets me a common denominator, and now I can combine my numerators. Okay, so really all this is doing is adding one step to it, and that is multiplying a second fraction to get a common denominator. Then once I have that, I can combine like terms, and I will state my answer just like that, and I do not need to simplify if I could. Okay. Again, biggest thing is find that common denominator, multiply it, okay, and combine like terms. So let's see about number 7 here. So number 7 says, I want to add x minus 1 over x squared minus 4 plus 3x over x plus 2. Recognize they broke down the first step for us. They broke down the original problem. So I have x plus 2, x minus 2. Now, the second problem already has x plus 2. So what am I missing? I'm missing the x minus 2. Does everybody see that? So now I need to multiply the numerator and denominator both by x minus 2. So when I multiply them, now I end up getting x minus 1 plus 3x squared minus 6x all over x plus 2, x minus 2. And again, all I did there is I distributed the 3x. Okay, I distributed the 3x. And now I'm going to look to simplify my numerator, combine like terms. And when I do combine like terms, I always want to write it in standard form. The standard form means the highest exponent comes first. So standard form would give me 3x squared minus 5x minus 1 all over x plus 2, x minus 2. And x cannot equal what two values here, Phil? 2 and negative 2. And there's your answer. Alright? So again, the biggest thing is you have to find what is the other fraction missing that you have to multiply by. Okay? Let's try number 8. I have 4x minus 1 over x squared plus 3x plus 2 plus 3 over x plus 1. So the first thing I want to do is I want to factor. Okay, I need to factor the left side. So that gives me 4x minus 1 over two numbers that multiply to get 2, add to get 3. Anybody? Multiplies to get 2, adds to get 3? 1 and 2. So x plus 1 and x plus 2. Plus 3 over x plus 1. Okay. So what am I missing now in my other fraction that I need to multiply by, Andy? I'm missing the x plus 2. So I'm going to multiply over here by x plus 2 over x plus 2. So I multiply by x plus 2 over x plus 2. Distribute that 3. And now I get 4x minus 1 plus 3x plus 6 all over x plus 1 and x plus 2. And now I look to simplify. Combine like terms. 4x plus 3x gets me 7x. Negative 1 plus 6 gets me 5. All over x plus 1 and x plus 2. And x cannot equal what two values, Bailey? Negative 1 and negative 2. There's your answer right there. Again, the biggest thing is you have to find what is the other fraction missing that you need to multiply by. Okay, and again, think of it as a fraction. What would you do? You need to multiply by and get a common denominator. Okay, and that's all it is. Find that common denominator. Good? Yeah. Now, try these 3, I'm going to cross off number 10 for you. Okay? If you want to challenge yourself, try number 10. But I'll cross off number 10. Because number 10, you have to actually multiply both fractions. So we'll cross that one off for now. Number 9 is just your basic addition subtraction problem. Okay? Try numbers 9, 11, and 12 then. All right, let's slowly start walking through these here. So number 9. Again, common denominators, you just want to add. What would you get for number 9, Miss Eby?
6x plus 8 over x minus 4.
Nice job. 6x plus 8 over x minus 4. That is great. Let's see here. Number 11, you'd have to factor it down first. Okay, number 11, you have to factor it down first. So you should have gotten x over x minus 4, x plus 1, plus 3 over x minus 4. So what's the fraction missing, John? The fraction is missing the x plus 1. So I'm going to multiply by x plus 1 over x plus 1. Then distribute. And when you do that, you get an answer of what, John? A final answer, sorry. So you get 3x plus 3, then you add it with the x up front, and you get 4x plus 3 all over x minus 4, x plus 1. Nice job. Okay. And number 12. Again, you want to factor down the left side. When you factor it, you should have gotten x over x plus 1, x minus 1, minus 2 over x plus 1. So what is the term that's missing here, Sean? It's missing the x minus 1. So I need to multiply by x minus 1 over x minus 1. And I distribute here. And really I could distribute the negative 2. Okay, because again, you see the negative 2 here. I could distribute the negative 2, just making it easier for me. I get x minus 2x plus 2 all over x plus 2. Or sorry, x plus 1, x minus 1. And now I look to simplify like terms, giving me negative x plus 2 all over x plus 1 and x minus 1. And there's your final answer. Again, the biggest thing is making sure you find that missing term that it is. Otherwise, when it's combined like terms, just like number 9, it's not too bad. Just add or subtract the numerators. If it says state the extremes, then do. I don't know, these didn't, but if it does say state the extremes, then yes, you would. Good question. Here is your assignment. And because we had shortened days today, I will give you the third assignment.